Hello everyone. My name is Venkata Swami, working as a associate professor in Marri Laxman Reddy Institute of Technology and Management and additional control of examinations. So as part of a Unit 3 module, polymeric materials, today we are going to discussing here conducting polymers. Conducting polymers, as you know, my dear students, as you know, understand polymers. The polymers, nothing but is a macromolecule, is a giant molecule, is a high molecular weight of substance which is formed by combining a many monomer units in the presence of temperature, in the presence of pressure, in the presence of catalyst. A bulk material is formed. A large molecular weight of substance is formed. And such type of polymer, a giant molecule, a macromolecule, which is said to be polymer. It's fine. Now, our topic is conducting polymers. So here, conducting polymers is a quite different for remaining topics. So those polymers, conducting polymers, we can define those polymers which conducts the electricity is called as conducting polymers. But all of you should remember one point. Most of the polymers, it may be plastic or it may be rubbers, whatever it may be, they are electrical insulators. But you know, our concept is some of polymers, those polymers which conducting electricity, and such type of polymers we can call as conducting polymers. But the reason is, so why these polymers which possessing the electricity? Why these polymers are which conducts the electricity? So what is the reason for this conduction of electricity of the particular polymers? So the main reason for this polymer which possessing the electricity is due to the presence of unsaturation. Due to the presence of unsaturation in the macromolecules. So what happens if the unsaturation is present in the molecule, a macromolecule? So here, when such type of polymers, when we are keeping some electrical field, so what will happen is, due to the presence of unsaturation in polymer, so unsaturation is nothing but usually the polymers which are consisting of pi electrons. And when these pi electrons containing a polymers, when we are exposed to, or when we are keeping some electrical field, so these pi electrons can be excited from the ground state to excited state level. So like this excitation of this particular macromolecules will be takes place entire through the polymeric backbone structure. So pi electrons are get excited from the one place to other place, one place to other place, one place to other place, so that there will be a chance to a passage of electricity because of the electrons are moving from the one places to other places. That is the reason some of the polymers which possessing the electricity. That's why, so those polymers which conducts the electricity which are called as conducting polymers. This is the story of conducting polymers. So yeah, let's see. So best example for this conducting polymers are polyaniline and polyacetylene, and polyphenol, polythioline, thiophene, etc. These are the best example for this conducting polymers. Therefore, these conducting polymers are, we can classify it into two categories. One is the intrinsically conducting polymers, and second one is the extrinsically conducting polymers. So intrinsically conducting polymers, nothing but already you know the conducting polymers definition. So intrinsic is nothing but within the macromolecules. That is, these have extrinsic conjugation in the backbone. And due to the presence of conjugation or unsaturation, both are similar. So conjugation, and due to the presence of conjugation, that's a double bond, alternative double bonds, double bond, single bond, double bond, single bond. So due to the presence of conjugation in the backbone, and which is responsible for the conductance. So that's this type of conducting polymers we can call as conducting, what is that? Intrinsically conducting polymers. So maybe this intrinsically conducting polymers we can divide into two categories. That is, conducting polymers having conjugated pi electrons in the backbone. I already mentioned the conducting polymers, what will happen? The conducting polymers are which are consisting, so having conjugated pi electrons. Conjugated pi electrons is nothing but single bond, double bond, single bond, double bond. So that second one is doped conducting polymers. Second one is, what is that? Doped conducting polymers. Let's we see is one by one. So first one is conducting polymers having a conjugated pi electrons in the backbone structures. Conducting polymers having conjugated pi electrons. The best example for is polyacetylene, polyaniline, polyphenol, polythiophene. So these are the best example for this. What is that? The conducting polymers which are having so conjugated pi electrons. So what will happening is, so these type of polymers have backbones of continuous sp2 hybridized carbon centers. All a conjugated pi electrons, or all conjugated pi electrons which are present in the backbone of the structure. Each and every carbon, and the conjugated pi electrons, conjugated double bonded compounds which are consisting of pi electrons, and each carbon containing pi electrons, or each carbon will possesses sp2 hybridization. In this case, in the conducting polymers, each and every carbon it will undergoes sp2 hybridization. One s orbital and two p orbitals, one px and py orbitals, they are combined with each other, and what will happen here? So the hybridized orbitals will be formed, and we have one more unhybridized pz orbital is there. Unhybridized pz orbitals. So that unhybridized pz orbital which is consisting of pi electron, and that unhybridized pz orbital, it does not participate in the hybridization. And that unhybridized pz orbital which are consisting of so one pi electron, and this pi electron can be excited from the ground place to from the ground state level to excited state levels. And entire this transition, electronic transition will be takes place entire through the polymeric backbone structure. Therefore, it will lead to the formation of some electricity in the conducting in the respective polymers. Let's see here. So one valency electron on each center resides in a pz orbital. So overlapping of conjugated pi electrons over the entire backbone results in the formation of a valency bond and as well as conduction bond. And this unhybridized pz orbital, it will lead to the formation of valency bond and as well as conduction bond, and which extends over the entire polymer. This type of excitation takes place entire through the polymeric backbone structures. But since this valency bond and the conduction bond are separated by a significant energy gap that we can call as band gap, and this conductivity of these polymers are not very high. See, for example, this is the acetylene, and there undergoes addition polymerization, and it will form a polyacetylene. And this polyacetylene is consisting of CH double bond, CH single bond, CH double bond, CH. So what will happen here? One sigma bond, one single bond, double bond, single bond, double bond, single bond, double bond. So due to the presence of this unsaturation, conjugative double bonds will be responsible for this conduction of this type of polymers. That's why, so this is the category of polymers which are having this conjugated pi electrons in the entire the backbone of the polymeric structures. Second one is doped conducting polymers. Yeah, this topic is very important. So doped conducting polymers, as you know, the concept of conducting polymers. Sir, what is the meaning of this doping? Doping. Sir, why should we discuss about this doping polymers, doped conducting polymers? Nothing but each and every conducting polymer. For example, you take polyacetylene or polyaniline or polyphenol or polythiophene, whatever it may be. These are the best example for the conducting polymers. So these polymers, it may be polyacetylene, it may be polyaniline or polythiophene or polyphenol. It will possess some conductance values because of due to the presence of unsaturation. But here doping, so why we are doing here doping is nothing but, and in order to increase the conductivity of conducting polymers. What is that? Here the concept of doped conducting polymers is the conducting polymers usually it will possessing some amount of the conductance values. So in order to implement or to increase the conductivity value of this conducting polymers, we are using here doping process. Here doping is nothing but adding up some impurities, and externally we are adding some impurities. Externally we are adding impurities to the conducting polymers for enhance or increase the conductivity value of this conducting polymers. And this phenomena is called as doping. And such polymers we can call as doped conducting polymers. So once again, I am repeating, doped conducting polymers, the main concept of doped conducting polymers are nothing but in order to increase the conductivity values of the conducting polymers, we are adding a small impurities from the external sources to the respective conducting polymers. So that what will happening? Here the conductance value of the conducting polymers are increases. Sir, it's a fine. But how the conductance values are increases? The big question mark is, so we are adding some impurities, it's fine. And what will happen here? The conductance values are increasing. But what is the main function of these doping materials? What is the main function of added the impurities to the conducting polymers? So what happening if you are added the impurities in conducting polymers? So that, my dear students, we can increase the conductance value of the conducting polymers by creating a positive charge or negative charge. Creating a positive charge and a negative charge on a conducting polymer backbone structures. So because of the conductance value will be responsible for, or else the conductance value of this, for example, in terms of solutions. So the conductance value of solutions mainly depends upon these ions. If the number of ions are increases, the conductance values are also increases. If the velocity of the ions are increases, the conductance values are also increases. That's why here also we are creating a positive charge, and the added impurities are creating a positive charge or negative charge and the conducting polymer backbone structures. So what will happening if you are creating a number of positive charge, if you are creating a number of many number of negative charges on the polymeric backbone structures, so that the ions are increasing in the conducting polymer backbone structures. Therefore, what will happen here? The conductance values are increases. That's why this type of conducting polymers we can call as doped conducting polymers. My dear students, here just if you focus on the added impurities will be responsible to creating a positive charge or negative charge and the conducting polymer backbone structures. So how we can create a positive charge and negative charge on the conducting polymer backbone structures? There is a big question mark. So that, my dear students, the added doped materials are third group elements or fifth group elements. That's a Lewis acids or Lewis bases will be responsible for creating a positive charge or creating a negative charge on the conducting polymer backbone structures. So in this way, so we can increase the conductance value of the conducting polymers. See, once again, let's see. The conductivities of polymers having conjugated pi electrons in the backbone can be increased. The conductance, what will happen? The conductivity of these conducting polymers we can increase. How you are going to increasing? By creating a positive charge or negative charge on the polymer backbone. By which process? By oxidation or reduction process. What is the meaning of oxidation? Or losing of electrons. What is the meaning of reduction? The gaining of electrons. In terms of Lewis acids, we have explained that in terms of Lewis acids or Lewis bases. And this process we can call as doping, and this process can be done in the two ways. The first one is oxidative doping or else P doping. Very good, important concept. P doping or N doping. P doping we can call as oxidative doping, and N doping we can call as reductive doping. So that, my dear students, we will see here. So P doping is nothing but, so it involves you're treating the conjugated you're treating a conjugated conducting polymers with Lewis acids. See, I already informed you. So how can you creating a positive charge or negative charge on the conducting polymer? That is by adding of impurities. So that impurities are nothing but we are adding Lewis acids or Lewis bases. And the Lewis acids will be responsible for creating a positive charge because of Lewis acids which are having the empty orbitals. So empty orbitals is nothing but it will having the capability to against the electrons. So therefore what will happen here, the oxidation process will be takes place. And the oxidation and here eliminating of electrons. And from the conducting polymers, so one electron is going to be eliminating, one electron is going to be losing. In this way, so we can creating a positive charge on the conducting polymer backbone structures because of we are added Lewis acids. Because as you know, these Lewis acids which attract because of empty orbitals are there. Empty orbital is nothing but it is having the chance to fill the electrons. That's why. So P doping can be defined as, or oxidative doping can be defined as, you are treating a conducting polymers. You are treating a conjugative conducting polymers with Lewis acids, and these added Lewis acids will create a positive charge on the conducting polymer backbone structures. And this process we can call as P doping or oxidative doping. Let's see, this is the complete structure of polyacetylene. Just now we have seen, and we are added here. For example, what will happen here? For example, Lewis acids, and what will happen here? So one positive charge we have created on the conducting polymer backbone structures. What will happen here? So valency bond and the conduction bond. There will be some Fermi energy gap. So here, this is the donor level and this one is the acceptor levels. So here we can call as polaron because of radical ion will be formed. A radical positive charge is formed and radical is also formed. So the radical and the conducting polymer which is consisting of one radical and a cation we can call as polarons. Radical ion we can call as polarons. So but this polaron is a delocalized radical ion. Right. See, next one, N doping. So are you understood? P doping. So P doping is nothing but the added impurities. The added impurities, nothing but Lewis acids we are adding to the conducting polymers, and these added impurities or Lewis acids will create a positive charge a positive charge on the conducting polymer backbone structures by adding of Lewis acids. Therefore, so we are creating a number of positive charges on the conducting polymer backbone structures, so that the conductivity of this respective conducting polymer is increases. And such type of polymers we can call as oxidative doping or p-doping or p-doped conducting polymers. And second one is reductive doping or n-doping. So reductive doping or n-doping is nothing but we are adding a fifth group elements. Nitrogen, phosphorus, arsenic, antimony, and bismuth. Fifth group elements. So in n-doping or reductive doping, so we are treating a conjugated conducting polymers. We are treating a conjugated conducting polymers by adding of a Lewis base. And the Lewis base is nothing but usually which are having some excess of electrons. And these electrons which we are adding to the conducting polymers, so that conducting polymers, what will happen? The negative charge is going to be creating. So creating a negative charge on the conducting polymers by adding of a Lewis base is called as n-doping or a reductive doping. Reductive is nothing but a gaining of electrons. So it involves the treating of a polymer with Lewis base like amines, primary amines or secondary amines or tertiary amines. Thereby, the reduction takes place and negative charge is created on the conducting polymer backbone structures, so that the conductivity of the conducting polymer, what will happen here? Increases. So, p-doping and n-doping, the concept is same. So, p-doping and n-doping, the major concept is we should increase the conductivity of the conducting polymers. That's why we are here discussing about the p-doping and n-doping. So, p-doping is nothing but you can increase the conductivity of the conducting polymers by adding of Lewis acids. Therefore, it will form a positive charge on the conducting polymer backbone structures. Second one, n-doping. So, n-doping is nothing but you are creating a negative charge on the conducting polymers by adding of a Lewis base, and this process we can call as n-doping or reductive doping. EHC. So this is the polar ions. We are adding some electrons, and here what will happen here? So negative charge, sorry, this is a positive charge. Here negative charge will be created on the conducting polymer backbone structures. So second one. So intrinsically conducting polymers is completed. Second one, extrinsically conducting polymers. So extrinsically conducting polymers is nothing but extrinsically. At p-doping and n-doping comes under this extrinsically conducting polymers. So extrinsically conducting polymers is nothing but externally added some ingredients. Some of the polymers conduct electricity due to the externally added ingredients to them. Therefore, polymers with conductive elements with the filled polymers, that's a blended polymers. The polymers with conducting elements filled. In these polymers, the polymer acts as a binder and which holds the conducting elements added, so that the polymer becomes a conductance. Examples of conducting elements are carbon black and metallic fibers and metallic oxides. A minimum concentration of conductive elements to be added so that the polymer becomes a conductor, and it is called as a percolation threshold, and the conductivity elements are added to create a conducting in the path of the polymers. Second one, blended conducting polymers. Blended conducting polymers is nothing but these polymers we can obtain by blending a conventional polymer with a conducting polymers. Just you are reacting. And this polymer which is obtained as a good chemical and physical electrical properties and mechanical strength. Example, 40% ferrol when blended with a conventional polymer, with the combination which gives a conducting polymer with good impact strength. Here 40% of ferrol is nothing but it's a conducting polymer. You are blending with a conventional polymer. Finally, it will lead to the formation of a conducting polymer with good impact strength. The strength is going to be increases. Blending is nothing but mixing. Next one, let's see applications of conducting polymers. This is one of the important question here. Applications of conducting polymers. First of all, so these conducting polymers are used in rechargeable batteries. Rechargeable batteries, which are comes under secondary batteries. rechargeable batteries, which is called as secondary batteries. Secondary batteries is nothing but, for example, lithium-ion batteries, chargeable, which are rechargeable. So most of the conducting polymers are we can use it in rechargeable batteries. For example, our cell phone batteries, mobile phone batteries, that is nothing but lithium-ion batteries are present. These are the best example for the rechargeable batteries. Second one, these conducting polymers are mostly used in analytical sensors of pH determination and oxygen levels, nitrogen oxygen layers, sulfur dioxides, nitrous oxides, or ammonia. Okay. These conducting polymers are mostly used in analytical sensors of pH determination of pH values of the unknown pH solutions. Simultaneously, these conducting polymers are used in photovoltaic cells. For example, we can see in the solar cells. In the solar cell, we can use it as the photovoltaic cells. In the photovoltaic cells, we can use it in these conducting polymers. For example, aluminum polymers and iron. A fourth important application is and used in telecommunication systems also. And most of the conducting polymers are we can use it in communication purpose in the telecommunication systems. Fifth application is used in transistors and diodes, PN junction diodes or NPN junction diodes or PNP junction diodes, and used in solar cells. And one of the most important application is used in wiring in aircrafts and aerospace parts. And these are the most important applications of the conducting polymers we can use it in various purpose. One is the rechargeable batteries, and the conducting polymers are we can use it in rechargeable batteries. The conducting polymers are used in analytical sensors and also used in photovoltaic sensors, used in telecommunication systems, used in transistors or diodes, and used in solar cells, and also used in aircrafts and aerospace parts. So these are the major important applications of conducting polymers. So this is the important applications of conducting polymers. And we can see here the reference of this conducting polymers. You can observe this slide share. Okay, thank you, and thank you very much. And next class we will discuss the last topic of this unit, that's a biodegradable polymers. Thank you, and thank you so much.